Dear students, firstly, I will introduce I myself, Professor S.H. Chaube, working as Assistant Professor in Electrical Engineering Department of S&D College of Engineering and Research Center, Yola. So, up till now, we have seen the breakdown in the gases. Then later on, we will go for the breakdown in liquid and solid dielectrics. And now currently, we are going for the generation of high voltages and the high currents. Generation of the high voltages and high currents. So in this case, we have seen up till now the generation of AC high frequency voltages. Then also we are going for the generation of high voltage DC, high voltage DC, right? So when we are going to study the high voltage AC generator or AC voltages, generation of that to AC high voltages, in that time what we have studied? We have studied the cascaded form, cascaded transformer. I have explained that cascaded means one is connected, one output is given to second input, just like with cascading. What is the benefit of this cascading generator, transformers? In this case, we know that for a large voltages, it is not possible to manufacture a single unit of the transformer. It is going to be very not economical also, it is not also achievable. So in this case, we have seen the cascade transformers, then later on we will go for the resonant frequency, depending upon the resonant frequency equation, we will go for the resonant transformers. Then later on also we also seen the Tesla coils for generation of the high AC voltages. Now we are coming for the next one, that is going to be the generation of the high DC voltages. So in this case, we have seen in the case of half wave rectifier, full wave rectifier, voltage doubler circuit, all these are the for generation of the high DC voltages. Now in this case, in this current current lecture, we will see what is the electrostatic machines. We are studying the electrostatic machines. In the electrostatic machines, they are classified as Van de Graaff generator. Van de Graaff, that is a scientist who invented the generator. So it is called as a Van de Graaff generator. And second one is the electrostatic generator. So what is this electrostatic machine? What happened in this case of? We have seen in the electromagnetic machine. What we have seen in the second year, third year electrical engineering, what we have studied? When a current carrying conductor is placed in a magnetic field or moved in a magnetic field, a mechanical energy is converted to electrical energy. It means EMF is generated. Now, what happened in this case of electrostatic machine? In this case, charged bodies are moved in an electrical field against the electrostatic field in order that mechanical energy is converted into electrical energy. What happened? Charged bodies are placed in electric field against the electrostatic field in order that mechanical energy is converted into electrical energy. So this is the principle. What we are saying up till now, what we are studying, second year, third year, electromagnetic machines. When a current carrying conductor is moved in the magnetic field, the EMF is generated. Now in this case, the case is going to be somewhat different. In the charged bodies are placed in electrical field against the electrostatic field, so that EMF is generated or the mechanical energy is converted into electrical energy. Now, what we have seen two types: Van de Graaff generators and the electrostatic machines. So, what is that? Van de Graaff generator is a device that creates high potential, electrical potential. You know that potential is the voltage. So, high generating voltage, we are using this Van de Graaff generator. If you are knowing something about the electrostatic field and static electricity, you can easily understand what is the principle of Van de Graaff generator. If you know basically what is the electrostatic field and what is the static electricity, you can easily state the idea of what is the Venn diagram generator say, or what is the Venn diagram has invented in the case of Venn diagram generator. It's a device which is designed to create static electricity and make it available for experimentation. To design to create a static electricity. This is a simple diagram. We will see explain the diagram later. So firstly, we will see that just I have told you that the American physicist Robert James Van de Graaff invented the Van de Graaff generator in 1931. The device that bears his name has the ability to produce extremely high voltages as high as 20 million volts. How? 20 million volts. You understand that how the capacity of the Van de Graaff generator to generate the voltages, higher voltages. Van de Graaff invented a generator to supply the high energy needed for early particle accelerator. These accelerators were known as the atom smasher because they accelerated subatomic particles to very high speed and then smashed them into the target atoms. The resulting collision created other subatomic particles and high electrical energy radiation such as X-rays. It was what is the invented in the case of that one Van de Graaff. Accelerators are put, they are used as atom smasher and they are going to generating the subatomic particles. The ability to create this high energy collision is the foundation of particle and nuclear energy. The ability to create this high energy collision is the foundation of particle and the nuclear. Van de Graaff generators are described as a constant current electrostatic device. Constant current electrostatic device. It means that is going to be constant current status. When you put a load on a Van de Graaff generator, the current remains the same. What is varying? It is the voltage that varies with the load. Constant current means Van de Graaff generator, the current is constant. What is the difference? Or what is going to be varying? Varying is the voltage. In the case of Van de Graaff generator, as you approach the output terminal with a grounded object, the voltage will decrease, but the current will remain the same. Current will remain the same. Now, conversely, it is what is the opposite side. It is what is the constant voltage. It is going to be that batteries are known as constant voltage devices because when you put up a load on them, the voltage remains the same. Batteries, you know, the voltage remains the same. Output voltage is going to be the same. Whatever may be the load on this one, load is going to vary the current, but it does not affect the voltage. But what is the Van de generator? It is a constant current. Varying parameter is nothing but the voltage. Current is constant. Say that when you put up a load on Van de generator, the current remains the same. It is the parameter which varies is nothing but the voltage. There are two types of Van de generators. Two types of Van de generator. First one, it is going to be the voltage supply for charging purposes. High voltage per power supply for charging, and one that other is belt and roller for the charging. Belt and roller for the charging. So up to now, syllabus is concerned, we are only studying the second one, that is going to be the belt and roller for the charging. Why it is called as belt and roller? Because the charges on these belts and rollers, they are going to be explained how the high voltage is generated in the case of Van de generator. We will see nextly what is that how that happens, that negative charge on the rollers and how the positive charge is created on the belt and how they are due to this one repulsion or all these other reactions, how the high voltage is generated in the case of Van de Graaff generator. So what is this consist of? This consists of nothing but a motor, two rollers, a belt, two brake assembly and an output terminal. See here. You will see in the diagram I have said. Here this is a simple principle. This is going to be two rollers. These two rollers are here. Here is a belt. Here is a vacuum pressure tank. Here is positive charge. Here is positive charge. Now there is a ground plane. Here is going to be the motor is going to be given here. Motor is connected to this roller. so that the motor will going to start, the rotor start to rotate. Again, these two pulleys are given here. That is going to be given in this way. So this is a simple principle of that one. Two types, and it consists of second one, roller and belt types. We are studying in this our as per our syllabus is concerned. So this kind of generator is made up of one motor, two rollers, a belt, two brush assembly, and output terminal. Just we have seen in the diagram. When the motor is turned on, what happens? Roller will start to rotate. That lower roller begins turning the belt. Roller को belt connect किया हुआ है, तो belt will also move. Roller will also going to move. Since the belt is made up of rubber, but lower roller is covered with a silicone tape. Now your question arises: what is the difference between silicone and the rubber? Silicon has the more number of negative or electrons or negative particles as compared to the rubbers. Silicon, you know that is a semiconductor. If some impurities are given, it is going to start to conducting. So this is going to be the silicon tape is covered on the lower roller, and lower roller begins to build a negative charge, and the belt begins to build a positive charge. What I have told in the starting, what is the basic principles of the Van der Waals generator? These are charge principles. That belt has the negative charge, positive charge, and the roller has the negative charge. What we have studied in this case of starting, I have told you, that is nothing but Van der Waals generator depends upon nothing but the electrostatic field and the static electricity. That I have just told you at the starting that the Van der Waals generator is base principle of that one, static electricity and the electrostatic field. The same principle is going to be used here. You can understand why this charge imbalance occurs by looking at the Triboelectric series. Silicon is more negative than rubber. Just I have told you that. Silicon is more negative than rubber. Therefore, the lower roller is capturing electrons from the belt as it passes over the roller. Therefore, the lower roller is capturing electrons from the belt as it passes over the. Why? Why do you? Because roller is made up of silicon tape, while the belt is going to be the rubber. Now the next point is the concentration of the charge. That is the main important. When you are studying the Van der Waals generator, that is important because this concentration of the charge, it may be negative or it may be positive. This concentration of the charge on the belt or on the roller is going to be affecting the working principle of the Van der Waals generator. So it is important, it is written here. It is important to realize that charge on the roller is much more concentrated than the charge on the belt. Charge on the roller is much more concentrated because why? Because belt is made up of the rubber, it is insulator, but roller is made up of the silicon tape. So there is going to be the concentration on the roller is much more as compared to the belt. Because of this concentration of the charge, the roller's electric field is much stronger than the belt's electric field. Surely it happens. More charge, more electrostatic field, more electrical field. So belt roller have surely the more electric field as compared to the belt electrical field. The strong negative charge from the roller now begins to do two things. The strong, just I have told you. Why it is going to be negative? Because there is going to be the made up of the silicon. The strong negative charge from the roller now begins to do two things. What the two things you will see? It repels the electrons near the tips of the lower brush assembly. Why electrons are going to be repelled? Because like charges repel each other and unlike charges attract each other. So what is on the silicon tape or the roller? There is a negative charge. So this repulsion of the negative charge, and metals are the good conductors because they are basically positive atoms surrounded by easily movable electrons. Know that you are also going to be final B student. You know that metals are the very good conductors of electricity. That is going to be. The brush assembly now has a wire tip that are possibly that are positively charged because the electrons have moved away from the tips toward the connection at the bottom motor housing. So there is a concentration. That is going to be very important. It begins to strip nearby air molecule of the electrons. It begins to strip nearby air molecules of the electrons. When an atom is stripped of its electrons, it is said to be plasma. You know that there are four states. Matter has the four states. First one, solid, liquid, gases, and the fourth one, that is nothing but the plasma. So they comes in the fourth state. What is the fourth state? That is the plasma. It is to be said to be plasma, the fourth state of the matter. Just I have told you. That is the solid, liquid, gases, and the fourth state is nothing but the plasma. So we have free electrons and positive charged atoms of air existing between the roller and the brush. Just I have told you that the concentration of the charges on the belt and on the roller that are sufficiently causing the high potential generation as the principle of the Venn diagram.